architecture, and what's not best then other than to talk about Spark Cache. So, what do you say? Should we take this word? Okay, I'll just continue here. So basically, Spark makes things faster. Previously, we had the Hadoop world, and then we have even bigger workloads. So X10 is not enough. Luckily enough, Spark provides us with cache. We can call DataFrame.cache, but we need to know when to use, when it's proper to use cache, when not to use cache, and how to use cache. Let's start with the technicalities of how to use cache. I think those are poisonous, so not recommended to eat those. Quite here. Okay, so how to use Spark DataFrame caches? We call DataFrame.cache, and the thing that it will do is basically take the data frame and cache it. Where would it cache it? In memory and also in disk. And we can control this with persist. Basically, we can say spark.persist and then control whether we want to persist it only on disk or also in memory. Great. Cache would persist it to both memory and disk if it has room in disk. Then if it has room in memory, then it would just cache it in memory. And if it does not have some room in memory, it would then spill it to disk. So this can be good for small data frames. I take it that if we have 1 terabyte of a data frame, then we would not want to load it to store it in cache and memory disk. We have other issues. We should treat this problem differently. About the technicalities of how to use the Spark data frame cache, let's see if there are some water down there. About the technicalities, we just call DataFrame.cache or DataFrame.persist and pass it with the constant of whether we want memory and cache. So we could have DataFrame.filter, no water, but a butterfly. Maybe he's also looking for some water. So we call DataFrame filter.filter.select, and then we have something and we want to cache it, so we just call DataFrame.cache even before we did any action. The cache would not take place at this moment. The cache would take place only when we run an action, like DataFrame.count. So it's quite common to see in code DataFrame.select.select.filter.filter.filter.map.cache.count. The person who did it wanted to materialize the cache, to make it happen. If he wouldn't, then no cache would happen. No cache would happen. Because what's the point of making cache if we have no action? So the next thing to consider is when to do a cache even at all. I think it's, as we said, it's good to make cache. It's possible to make cache if we want things to be faster. If things are fast enough, do not mess with it. It only adds complexity. If things are fast enough, then no need for cache. We can cache both SQLs with cache table and then the SQL. And it's also, and we can cache the data frame. So we have the Spark SQL where we cache inside the SQL. We say cache the table in the SQL. It's part of the standard SQL syntax. And we can also use the programming object DataFrame.cache or .persist. So the thing here, the next thing is to consider what do we cache. If we also have a data frame with 100 columns, and we need only one of them, then we don't want to cache the 100 columns. We first want to select the only column that we need, and then to cache it. So this is also something we should be careful. If we don't know how many columns, we don't want to load this everything into memory and disk. It may end up consuming even more time than not caching it. So one use case of not caching is if we have many columns, we want to first select only the columns that we want, and then if we have a big, like tens of gigabytes or hundreds of gigabytes, we don't want to cache this because it would consume only more time than not caching at all. Another important thing to remember is that we want to call explicitly on the Spark session. The Spark session is we first start the Spark, we have a session, and we start working with it. As long as we do select, diff, filter, we are in the same Spark section. We want to unload things. Spark, if it fills the cache, then it would LRU style list reset. It would try to insert something to cache if you want to cache it. If you don't have enough room in the memory, then or in disk, then it would unload the list recently used, and this would take even more time. So basically, when we finish the operations, we don't need this. We want to just to unpersist everything, uncache everything. In the SQL syntax, it's uncache table, I think, or yeah, uncache table or something like this. And in the programming notion, it's unpersist. And we can call also spark.catalog.clearCache, which hopefully will clear everything from cache. As you see, we are a little bit messing with this, so only if it's really needed. It's increasing the complexity of the software. Another thing is that once you did DataFrame.cache, let's say you have df1, df2, df3, and you did, if you only have one data frame, one object name, and you do .cache somewhere and then you lose this reference, you call another function, you don't have this reference, how will you reference this cache? So in tables, it's easier because on tables, on Spark SQL tables, you could just call this view name again with create or replace view and then cache it. So it's also good when you use the objects to store this reference of this object, of this object, and store this reference. So if I cache df3.cache, then I want to store this reference because later on I would need to use it. So usually when we do a cache, then we want to store the reference to the object so that we can reference this. Okay, and with that we'll wrap up our first video update from the outside world.